Okay, it's recording. Good evening, teacher. My name is Joel Bachman, and today I'll be presenting our physics project relating to Pascal's principle. Tonight, I am accompanied by my friends, Sneha Shankar and Shibun Ping.
Hello.
Hi. Hi, Bupeng.
Hi, Joe.
Hi.
Hi.
Hi. All right, Bupeng, mind doing the introductions?
I don't mind actually. So for the introduction of this project, Pascal's principle states that the pressure applied on an enclosed fluid is transmitted uniformly in all directions in a fluid.
All right.
So for the activity objective, design and build a hydraulic system.
Yep. And Sneha?
The problem statement, how to produce the larger output force, and the concepts applied are the Pascal's principle. It is applied as a means to obtain a larger output force.
All right, thank you, Sneha. So moving on to the procedure. So the following materials are prepared: a cardboard box, a scissor, two syringes, a hot glue gun, and a super gun, and a silicone tube. Moving.
So the cardboard is then cut into several pieces as follows. So we are cutting one 20 cm by 50 cm cardboard, one 8 cm by 8 cm cardboard, two 7.5 cm by 2.5 cm cardboard, and lastly, three 14 cm by 8 cm cardboard.
All right, so a 20 cm by 15 cm cardboard will act as like a base for our entire system, and the 8 cm by 8 cm will be pasted on top of the syringe to support objects on it, and these three here will be used as the walls to support the system, and these two will be one that will hold the syringe. It is all be shown
Correct.
later on in the procedure. All right, Sneha.
The cut cardboards are then glued as shown in the photo.
All right. To these the walls I've mentioned before. All right. For the fourth step, as I've again to bring back my point is that these two smaller cardboards that I cut it will be pasted in this manner, which then we will paste the syringe on it. So these two act like it's like a support for the syringe. Bunping, mind carrying the fifth step?
So the 8 cm by 8 cm cardboard is then glued to top part of the syringe as shown in the photo.
Yep, this would be the base for the object. And Sneha?
A hole is then drilled to the side of the cardboard, and the silicone tube is then connected to the syringe opening.
I realized that there was a mistake with the numbering, so this is supposed to be the sixth step. So
Precisely.
let's just keep that in mind. This would be the seventh step. Right. So another syringe, as you can see, is then connected to the other end of the silicone tube, and colored water is filled into this tube, and of course the syringe. This water will then act as the hydraulic fluid to transmit the pressure from one end to the other end. Shibun Ping? For the wait, this is the 7, this will be the 8th step.
So then the second syringe is glued to the base of the cardboard.
All right, as you can see in the photo. So this then will then
for easier
conclude.
access.
Yep, this will then conclude our product, and we'll see this video which shows the function of this system. As you can see, I apply a pressure, and the pressure then transmit the force from the input to the output to the other end of the syringe, thus covering the tiger balm ointment. All right, Sneha?
In conclusion, we have proven that Pascal's principle can be applied in a hydraulic lift. Pascal's principle states that the pressure applied on an enclosed fluid is transmitted uniformly in all directions in the fluid. Thus, by applying Pascal's principle, the tiger balm ointment can be lifted up.
All right, and Chumping, mind telling us the other applications for Pascal's principle?
So the other applications for the hydraulic system are hydraulic jack, hydraulic brake, hydraulic piston, and hydraulic motors.
All right, that concludes our presentation today. Thank you for watching, and I hope you can give us full marks. Thanks, teacher.
Thank you,
Thank
teacher.
you,
Bye.
teacher.
Teacher, bye bye. Good
Bye.
night. Good
Good
night.
night.
Good night.
Good night.
Okay, okay. Go and sleep or turn